Dear students of class 12, how are you? I think all of you are well by the grace of Almighty Allah. I am also well. I am MD Asghar Khan, Senior Lecturer, Department of Mathematics. Today I want to discuss about your Higher Mathematics, Chapter 3, Complex Number. Okay, this is our MCQ portion. How we can give answer in MCQ part by using some technique. Okay, first one, what is the value of 2i to the power minus half and minus 2i to the power minus half? How we can find this value? Okay, at first 2i to the power minus half and minus 2i to the power minus half. Okay, how we can write it? Minus half, that means 1 by root over 2i, and it also write 1 by root over minus 2i. Okay, and 2i we can write it 1 plus 2i minus 1. And it can be write 1 plus 2i minus 2i and minus 1. But ultimate number not be changed. Okay, so by this calculation, this is equal to 1 I square, minus 1 is equal to I square, and it also I square. So 1 plus I whole square by the root only 1 plus I, and this is I square 1 minus I whole square. This is 1 minus I. Then 1 plus I, 1 minus I. Then by the LCM, 1 plus I, 1 minus I, and it will be 1 minus I plus 1 plus I, and 2 divided by 1 minus I square. I square is equal to minus 1. So 2 divided by 2 is equal to 1. So our answer is 1. So this is the MCQ number 1. Now MCQ number 2. Okay. Now MCQ number 2. MCQ 2 is I to the power 4n minus I plus I to the power 4n plus 1 minus 1. Okay, my dear student, you have to memorize how we can find the value of the power of I. It is easy. Just you think you have to memorize I square is equal to minus 1, I cube is equal to minus I, and I to the power 4 is equal to 1. If you memorize these 3 power of I, then you can find out the other power of I by using this. But in this case, I to the power 4n, I to the power 4n, that means I square to the power 2n, and minus I plus I to the power I square into 2n minus 1. Just you think I square is equal to minus 1. I square is equal to minus 1, 2n. Okay, 2n is an even number for all values of n. For all values of n, 2n is always even number. So for even number, if minus 1 is even power, then it will be always 1. Okay, as an example, minus 1 to the power 4 is equal to 1, but minus 1 to the power cube is equal to minus 1. According to these rules, this is minus 1, this is I, and this is also minus 1, and this is I to the power 4n plus 1, but in here I to the power 4n into I minus 1 and I to the power 4n into I minus 1. Okay, so this is our 1, this is 1 into I minus 1. So minus 1 minus I plus I minus 1. Then this is also 1. Okay, so is equal to 0. So our answer is 0. C is our answer. Okay. Now question number 3. Okay. Question number 3 is I to the power m plus I to the power m plus 1 plus I to the power m plus 2 and I to the power m plus 3. Okay. I to the power m plus 3. How we can find it? M is the element of z. Z means integer number. Okay. Just you think m is equal to is the element of z. That's why you can think any number. It's 0, 1. Okay. Just like m is equal to 0. Okay. I to the power 0 plus I square plus I cube. I to the power 0 means 1 and I, and it's also I square is equal to minus 1. I cube is equal to minus I. Okay. Then is equal to 0. So answer option is C is our right answer. Okay. Now in question number 4. Question number 4 is I to the power minus 70. I to the power minus 70 plus 1. How you can write it? 1 by I to the power 70 plus 1. But it is our question how we can find I to the power 70. So at first 70 is divided by 4. Then 70 divided by 4, it will be 70. Then this is 68. Then remainder is 2. So our remainder is 2. So I to the power 70 equivalent to I square. If the power of I divided by 4, then remainder is 2. So I to the power 70 is equal to I square. So it is always, this is our process. If I is power greater than 4, then it is divided by 4. You will get your answer. The remainder, then I to the power 70 is equal to I square. Okay. So we can write it plus 1. So 1 by minus 1 plus 1 is equal to minus 1 plus 1 is equal to 0. So our answer is 0. So it's another example for I. If I to the power 7. So 7 is divided by 4 is 1. So is equal to 4 is equal to 3. So I7 means I cube. I cube means I. So we can easily find the value of the power of I by this process. Okay. Now our next, now question number 5. If 2 plus 3i, 2 minus I is equal to a plus I, b. And what is the value of b, where a and b are real number. Okay, my dear student, here 2 plus 3i and 2 minus I, this is the complex form, but this is not the form of a plus ib. That's why at first this complex number convert into this form, and for this calculation you always remember, and the denominator is 2 minus I. So what is the conjugate of this? 2 plus I. Always the conjugate of denominator multiply by numerator and denominator. By the conjugate of denominator multiply by numerator and denominator, then this expression convert into this. Okay, and by this way 2 plus 3i, what is the conjugate of 2 minus I? 2 plus I, multiply by 2 plus I. Okay, then in denominator, by applying the algebraic formula a minus a plus b into a minus b, a square minus b square. In numerator, multiply by the 2 bracket. At first multiply by 2, 4 plus 2i, and multiply by 3, 6i plus 3i square. It will be 4 plus 8i minus 3. 4 I square is equal to minus 1. Then it will be plus 1. 4 minus 3 is equal to 1 plus 8i divided by 5. And we can write it 1 by 5 plus I of 8 by 5, which is in form of a plus ib, which is the expression of a plus ib. Just two complex number are equal, what will be happen? Their real portion and complex portion and imaginary portion are equal. So a is equal to 1 by 5 and b is equal to 8 by 5. That means what is the value of b? B is equal to, our value is 8 by 5. So our answer is D. Okay, now question number 6. Similar question, similar type question. How you can solve it? Just it also similar process. 2 minus I, 2 plus I. How we can convert into this expression? Rule say conjugate of denominator multiply by the conjugate of denominator multiply by numerator and denominator. Okay, this is 2 minus I, 2 minus I, 2 plus I, its conjugate is 2 minus I. Okay, multiply by numerator and denominator. Then 2 minus I whole square, 2 square minus I square by the algebraic formula. In above part, a minus b whole square, a square minus 2ab into b square, and 4 plus 1, I square is equal to minus 1, minus minus plus. So 4 minus 4i minus 1 divided by 5 is equal to 4 minus 1 is equal to 3 minus 4i divided by 5. So 3 by 5 minus I into 4 by 5, okay, is equal to a plus ib. Okay, what is the value of a now? What is the value of a? So a is equal to 3 by 5. A is equal to 3 by 5 is our answer. Okay, now what is the principal argument of this? Okay, now how we can find the argument of complex number? Just you have to memorize this process, then you will find out the argument of a complex number. But by how? Just you think, if complex number z is equal to x plus iy, it lie in first quadrant, any complex number. This is x axis is the real axis and z axis is a complex by imaginary axis. If any complex number is lying first quadrant, assume x is a real value and y is a complex value lying y axis. By this process, if the complex number lie in first quadrant, then argument z is equal to tan inverse y by x. If complex number lie in second quadrant, so the value of x will be negative. So minus x. So argument z is equal to pi minus tan inverse y by x. Okay. If the complex number is third quadrant, so x and y both are negative. So argument z is equal to minus pi plus tan inverse y divided by x. Okay. If the complex number lie in fourth quadrant, where x is positive and y is negative, minus x plus x minus iy. Okay, if it is in fourth quadrant, then how we can find? Argument is equal to tan inverse y by x. Okay, just you have to memorize this process. If lie in first quadrant in this and lie in second quadrant, x will be negative. The value of real axis will be negative. And here real and complex axis both are negative. Value is negative. Here imaginary axis will be negative. Then it is fourth quadrant. Okay. Now how we can find this principal argument of minus 3 minus 3i? At first, okay, by this process, minus 3 we want to find minus 3 minus 3i. Minus 3 minus 3 minus 3i. Okay, minus 3 minus 3i. Which quadrant is lie? Just x is negative, minus 3. Just think this is minus 3 and this is also minus 3. So it lie in it is z, then it lie in third quadrant. So argument is equal to, in third quadrant, minus 5 plus tan inverse y divided by x. So minus 5. Tan inverse y, this is y, this is x. Okay. Tan inverse 1 is equal to 5 by 4. Okay. So minus 4 pi plus pi minus 3 pi by 4. Answer is minus 3 pi by 4. It is D. Okay. Now in also this, z is equal to this, and what is the argument of z bar? Okay. What is z bar? What is z bar? This is the conjugate complex number. Here z is equal to minus 1 plus I. Then z bar is equal to minus 1 minus I. That's conjugate portion of complex number. Conjugate of complex number z bar. So we want to find this is which one is the argument of this, and which quadrant lie? It also lie in third quadrant. In third quadrant, argument is equal to minus pi plus tan inverse y by y divided by x. So minus pi plus tan inverse y means 1, x also 1. So 5 by 4. It also be minus 3 pi by 4. Okay. It also be minus 3 by pi 4. Answer is A. Okay. Now question number 9. What is the represented by modulus of z is equal to 1, and what type of geometrical shape by this complex equation? Okay, so this is z modulus of z is equal to 1. Okay, so modulus of z is equal to square root of real summation of square of real portion and complex portion is equal to 2x square plus 3y whole square is equal to 1 by square both sides. 4x square plus 9y square is equal to 1 by the square in both sides. Then we can write it x square divided by 1 by 4, and it also we can write it 1 by 9 is equal to 1, which is compared with x square divided by a square plus y square divided by b square is equal to 1, and this is the standard equation of ellipse, and this equation is comparable with the standard equation of ellipse, so this is ellipse. Okay. Now in this, and what type of represent this? Z and Z bar is equal to 1. Okay, now how we can find it? Z and Z bar is equal to 1. Okay, yeah, Z is equal to x plus iy. This is our complex number. Z x plus iy, and what will be the Z bar? X minus iy. So Z and Z bar is equal to x plus iy into x minus iy. So by the algebraic formula a plus b into a minus b, it will be x square plus iy whole square. So x square minus a square minus b square. Okay, so x square plus y square, and there here z and z bar is equal to 1, so x square plus y square is equal to 1. It is easy to show. This is the equation of circle. Okay, now in this question number 11, x is equal to minus 1 plus root over minus 3 divided by 2. Okay, it is our complex root of unity is omega is equal to minus 1 plus root over minus 3 divided by 2. This is the complex root of unity. We know this is omega, another one is omega square, if it will be minus. Okay, now x plus this is equal to x, so x is equal to omega, so x plus 1 by x is equal to omega, and 1 by x also be omega. So omega is our LCM. Then omega square plus 1, we know 1 plus omega square is equal to 0. By this is minus omega, and this is omega is equal to minus 1. So answer is minus 1a. Okay, this is our today's class.